It is time to put it all together. Let's put it all together. We've simplified, we've added, we've subtracted, we've multiplied. Let's make some sense of what in the world we're doing in this graphing world. So the first thing we're going to do is, of course, go ahead and simplify what we can see. So out of this problem, numerator, we got x minus 6 and x plus 4. Denominator, x minus 4 and an x plus 4. Alright, so that answers my first question. Domain, the restrictions are x. You are not allowed to be positive and negative 4. Now let's determine which one is which. So I do have an x plus 4 that can cancel out. Keep in mind, if they go away, that creates a hole. So the hole is at x equals negative 4. So the VA must be the positive 4. So let's go ahead and mark that VA right now. So we're going to have at positive 4, 1, 2, 3, 4. I have a vertical asymptote that we will not pass through. Next thing we'll check is the degrees. So I'm focused in on the highest degree. We have a complete tie right here. If we have a tie, that means we're going to go to the coefficients. And if we have the coefficients, that's 1 over 1. So y equals 1. So here's the next piece that we have. I'll extend that to the left as well. So those are the vertical and horizontal lines that this graph will never, ever cross. If we want a y-intercept, we're going to make x 0. So we're focused on the back side of this equation. So negative 24 over negative 16. Let's see, it's negative over negative, so it's positive. Let's divide by 8. So we got 3 over 2. So 1 and 1/2. So 0 with 1 and 1/2. Alright, so that gives me a pretty good idea that we're going to have a branch over here on the left. Let's see if we have any x-intercepts. X-intercept is when y is 0. And the nice thing about that is that's the numerator. So that means at 6, 0. The other one we would have is negative 4, 0. But I'm going to cross that out right away. We have a hole in the graph there, so that's not going to happen. So 6, 4, 5, 6. So we have that point over to the right. And negative 4, 0, that's going to create a hole, so we won't list that as an x-intercept. But what we'll do is make sure that when we get to negative 4, 1, 2, 3, 4, I'm going to put a circle in here so I know that that should not be part of my graph. Alright, so we're going to go ahead and sketch this bad boy out as best we can here without zooming too much more. There we can see everything that's going on. So the x-intercepts help me identify where the branches to this graph are going to be. That's the whole process. So by all means, if you have it, then go ahead and skip to the end here. Make sure you got everything. Check it out. Otherwise, hang with me and we'll kind of work through each one. Process is going to be exactly the same. Hopefully no surprises here. So 4 is a GCF. We got x minus 4 after that. In the denominator, I'm hoping for an x minus 4. And I should have one with an x plus 3. So first thing I'll do is say the domain, you are not allowed to be 4 and negative 3. So we're going to have a VA at x equals negative 3 because it's going to stay. The hole is going to be at x equals positive 4. How do we know that? Because they were just removed. Remember, those are removable. So that's what we're going to deal with. We have a degree of 1 over degree of 2. So horizontal asymptote is 0. Let's get some things on the graph because we have a lot of good information here and I don't want to forget what is what. VA, negative 3. 1, 2, 3. Vertical line. We will not cross over. Horizontal line is the x-intercept. And we're not sure where, but we do have a hole, so we're going to make sure we don't put anything on the right-hand side where there's a 4. So we'll get to that. Y-intercept, that's when x is 0. So we're focused on the tail end of our equation, negative 16 over negative 12. Both divisible by 4, so 4/3 turns positive, 1 and 1/3. X-intercept is 1 1/3, so that ought to do there. So it gives me an idea of where the graph is going to be. Let's look for an x-intercept. Okay, that's going to be based on the numerator. All I can get is 4, but notice we have a hole at 4, so this does not exist. All right, I don't want to list a hole someplace where we have vertical intercept asymptote because it won't exist. Okay, so we're going to head on through here. We're going to be careful because we do have a hole when we get out to 4. 1, 2, 3, 4. Put a circle in there so I don't forget. All right, and for the other side, they are going to be cat-a-corner of each other. Alright, so not too bad. Just trying to put everything on the graph as we solve it. I think that's the best way to deal with it. Alright, one more together here, and then some time to think about what you're going to do with it. 6, we want 1, so that's 3 and 2. And x minus 1, so x, you are not allowed to be 1. That is a vertical asymptote, so here I go to the graph already. X is 1. Well, that one got a little wavy. I guess there's a line tool in here, isn't there? Did we try it? Why not? Let's try it. What else are we going to do? Oh boy. Well, I don't want that line. Let's clean that up a little bit. It'd be nice if we could make a dash line. That'd be even better. Okay, that looks pretty good. Man, see, I'm learning too. I'm learning. What do we got here? We have a 2 is the clear winner up here. So we do not have a horizontal asymptote. We're going to have an oblique asymptote. So that means we're going to do some synthetic division. 1, -1, -6. We're going to add it up. We're going to drop the 1. 1 times 1 is 1. We add it up to 0. We get 0. We get -6. That would be the remainder, so we don't really care about it. Y equals 1x. Y equals 1x. Okay, now, of course, we don't need to write the 1x. I just want to make sure that we understand that this is going to be a slope of 1. So this diagonal line right here, that'll take care of everything we need. Do we have any holes in the graph? No. So it does not apply here. A y-intercept, that's when x is 0. So we're going to focus on -6 over -1. So 0, 6, 0, 1, 2, 3, 4, 5, 6. There you are. And an x-intercept, and that is solving that there numerator. So we got +3 with 0, and -2 with 0. We got 2 of them. Alright, -2. And let's jump off to the right. 1, 2, 3. Alright, so as long as you go through these 3 points, then we're going to be in pretty good shape. Okay, if I want to know exactly what's going on, then we will go through Desmos and get some exact points in what's happening in the world around us. Okay, but that's how we graph it. We've been working on this to simplify the expression, and now this is where those dividends pay off of all the work you have done. Okay, so just a chance here to try and map out, think about what's non-removable, what's to match up to. Hopefully when I say that, you're thinking there's a hole in the graph, you're thinking that means it canceled out. So just a place to kind of jot some ideas and reflect on all the things you know about graphing. How well did you do? Well, I'm right where I should be. Alright, what about you? Questions, concerns, as always, hit me up. Let me know what's going on.